Obviously, we don't have like a formal like guest speaker today, so I'm talking to you. I know you're all excited about that. I know a lot of you guys mentioned that you're interested in hearing more about circuitry, especially like as it applies to your project, so kind of like practical applications of circuitry. So I went around this morning and I kind of like asked everyone like, what would you like to hear about in circuitry? So I heard like setting up. So basically a whole bunch of things I'm just going to type in here. So setting up pins for serial, like RX/TX. I heard analog versus digital. I heard PWM, I2C, SPI. So basically I'm just going to put all these down and just you guys, by show of hands, tell me who wants to hear about these topics, and I'll go through as many as I can during like the 30 minutes. And I'm going to focus less on the theoretical and more on the practical, so it can be helpful for your projects. Cool. So, let's see. I just have Y though written down as a bullet point. Not really sure what that's about. Cool. So first of all, let's go through the. Actually, does anyone have any other sort of like circuitry topic they'd want to hear me talk about during this period? Spell that. Oh god, I'm just making it worse. Cool. Any other like topic anyone want to hear about? Oh, these? Can everyone see these?
I cannot read them.
Cannot read these? Oh, okay.
Can you make it like big? Or like just like zoom into it.
Is that good? Alright, so let's go through them. By show of hands, we want to hear about like what RX and TX is, what serial is, and how to set that up. Okay, seems like a good number, so like it's about maybe 80 or so I'm going to estimate. Who wants to hear about analog versus digital? It's definitely a really popular one, maybe like 10 or so of you. I'm just guesstimating here. What about PWM? Okay, so like 2 people. I2C? 2, 3. I'm just going to go through them by order of popularity, basically. SPI. Oh, one person cares about SPI. Pullup Resistors, what those are, how to use them. 1, 2, 3, 4, 5. Okay, 5. What is ground? What is common? What's the deal with that? Why do we care about ground? It's like, it's only 6 or 7. Can you add more pins on an Arduino? And if so, how? 1, 2, 3, 4, 5. Cool. Overview of like Raspberry Pi. What is it? How to use it? 1, 2, 3, 4, 5. I think I saw 5. Another review or simplified version of Ohm's law. 1, 2, 3, 4, 4. Okay. And then parallel resistor calculations. Cool. 1 person. So. Unless anyone has any other suggestion, I will start off with analog versus digital.
How to like connect Arduinos together.
Connect Arduinos together? Okay. Who would want to hear about connecting Arduinos together? So it looks like 3. Anything else? And then I'll get... Okay, cool. So let's get started on like the difference between analog and digital. Does anyone... Actually, can someone tell me, I'm going to go around the other side to the dry erase board. Can everyone see the dry erase board as well? Cool. Does anyone want to tell me in their own words what the difference between analog and digital is?
So analog is like input and range of values, while digital is like 0s and 1s.
Yeah, exactly. And on the Arduino, does anyone know in terms of output and input, like where you'd be, like, are there specific pins for analog input? Yeah? Does anyone know if they're like labeled or anything? Yeah, there's like A0 through A5, exactly. So in the Arduino, so yeah, the difference basically is for analog, we'll talk about analog over here, and then digital over here. So like Sushi said, analog is like a range of values, right? So an analog signal would look something like this. So you could see like, I don't know, if this is voltage, and this is, I don't know, like time or something, so it's just a signal over time. Like, the classic is like a sinusoid, right? Like, it can take on any value in between. So for example, with your Arduino, when you read from an analog signal, does anyone know what the values you get are? So let's start with digital. What are the values you get for digital when you read that?
0 and 1.
0 or 1, high or low, 5 volts or 0 volts. So has anyone used an analog sensor yet, or the analog pins? What values were you getting? Just shout out like anything. Do you remember like any of the numbers you were reading, roughly? Okay. Does anyone like remember using like an analog sensor?
I think I heard like 93, something like that.
Yeah, so it actually, the max value ends up being pretty close to that. It ends up being 1,023, and the minimum value is 0. So technically, it's not infinite. Like true analog would be absolutely anything between 0 and 5 volts. But instead, what they basically do is, with analog read on the Arduino, what they'll do is you'll have a value between 0 and 5 volts, some value in between there, right? Let's say that you had the value, I don't know, 2 volts. Well, they have, because it's a computer, they have to eventually take on some definite value, right? Like a computer can't like store like 3.333333, whatever, right? Infinite. So eventually it has to cut it off. And what it does is it cuts it off at a total possibility of 1,024 values. Does anyone know why actually it'd be 1,024, that specific number? Any guesses? It's slightly more than byte. It's 10 bits. So because 2 to the 10 is 1,024, so it's 1,024 different values it can hold. So let's say that input was 2 volts, right? So it needs to take on a value between 1,023 and 0 with 2 volts. Well, the maximum 5 volts will correspond to what? Does anyone want to tell me?
10.3.
Exactly. So this is the 10. So this is if you input 5 volts to the analog sensor and you said, what is it? Arduino would tell you 1,023. If you input 0 volts, it would tell you 0, right?
So then you connect like a separate battery towards it, like it's like 6 volts, then what does it?
It'll cap off at 1,023. It can't go any higher. Yeah, that's a good question. And then also, if you fed it a negative voltage, which is possible, it would go 0. It can't. So basically, it has to work within those bands. It caps off at either end. That's a great question. So then if you give it 2 volts, does anyone have any guesses about what it would do? Or like what the math going on there would be? So basically, what you'd do is you'd say, okay, it's 2 out of 5, right? 2 out of my maximum. And you multiply that by 1,023, right? Because what it's basically doing is 2/5 of the maximum. Versus, or maybe you read 1.6 volts. It'd be 1.6 over 5 times 1,023. Does that make sense? You're basically saying, what fraction of the maximum possible value is it? And multiply that by what that maximum, like the sort of like digital value takes on. Does that make sense in terms of analog? Digital, like Suchi was saying, like you guys have said, is just 1 or 0, high or low. Actually, can anyone guess though, what if you fed it like 3 volts? What would happen? Any guess? Yeah, I don't really know either. It actually depends upon, where's my eraser? Oh. Anyway, I'll erase it in a second. It actually depends on something called like a noise margin. So, thank you. So, generally speaking, you have the 5 volts, right? And the 0 volts. But when you input to it, right, you're not going to have exactly 5 volts for low. You're not going to have exactly 0 for high and exactly 0 volts for low. So what it has usually is, it says like, so long as you're like near 5 volts, I'm going to read a high. And so long as you're near 0 volts, I'm going to read a low. So that's like your margin for noise, your margin for error. So depending on how large the noise margins reach, tells you whether you'll get 5 or a 0. So yeah, basically you guys gave a good answer when you didn't answer, because I don't know what to give you if I put in 3 volts either. That's sort of the gist of how analog works with Arduino, how to use it. You have any other questions about analog or digital? Cool. If you have any other questions, you can feel free to ask. I'll move on to the next thing, which was how many votes? So with 8 votes, yeah, setting up pins for serial, RX, and TX. Does anyone know another name for serial? Like when people say serial, what do you know what they're referring to? Does anyone like any thoughts on serial?
1s and 0s, binary.
Yep, 1s and 0s, binary. What do you guys use serial for in your projects?
To send data.
Send data? Yeah, cool. What are you sending data between?
For me, it's a sensor in my computer.
Yeah, sensor in your computer. Great. You can send data between sensor and the Arduino, Arduino and your computer using serial. So another name for serial is, in this case, it's UART. and I will like give 1,000 imaginary points to anyone who can tell me what that stands for. Stands for Universal Asynchronous Receive Transmit, which is an acronym that no one cares about, which is why I know it. So basically the point of serial, like we say, is to communicate between devices. And there's an RX and there's a TX. And both devices have an RX and TX, right? So if I have an RX and TX here, so this is 2 and this is 1. So anyone want to tell me how I'd connect them? What would I connect RX1 to? So say this is like one, yes, let me make it clear. Let's say this is our Arduino. And then let's say that this is like some sensor. So what were you saying, Crit? Exactly, yeah. RX1 goes to TX2, and then where's TX1 go to? Exactly, yeah. Because R stands for receive. So receive is getting from transmit, and then transmit's saying to receive. So that's a tricky thing with them, is you have to make sure that they sort of cross match. You don't go TX to TX, you go TX to RX, and RX to TX. And what's really going on here is they have specialized hardware to kind of interpret that sort of signal of zeros and ones that Charles mentioned, right? It's sending a series of zeros and ones. And they have specialized hardware to say, when this guy basically, normally what's happening with TX, so TX basically has control of the line, right? There's a wire between this one and this one. You can also stop me at any point if I say something that doesn't make sense. So TX is connected to RX, right? And let's say the Arduino wants to send a message to the sensor. Well, what Arduino has to do is it has to tell the sensor, hey, I'm going to start sending a message, right? So what it will do is normally this line is holding it high. So basically normally the Arduino is basically making that wire sit at 5 volts. Then what it'll do is it'll pull it down to say, hey, I'm going to start talking to you. The tricky thing though is how do you interpret, for example, if I send this, say this is the TX Arduino, right? So here's 5 volts and here's 0 volts. And it pulls a load, it says, great, time to start the message. So this is like a sort of start bit. How do we know if it then goes like this? Like, how is this guy supposed to know that the start bit ends here and then this is a 0 and this is a 1 and this is a 0 and this is 1? On the other hand, it could have just as easily been like the start bit is this whole entire thing and then we get to 1 here. Does anyone have any guesses how the sensor would know that the start bit ended here? Basically how long it is? When you were using serial, what were some of the parameters you had to play around with? Does anyone use serial.begin? What do you put in serial.begin? Yeah, and do you know what that is? What were you saying?
It's like the thing that you have with the serial that you have to, like it's the translation.
Yeah, so you put in the code and you also put it on your computer, right?
Yes.
So if your computer and your Arduino are both agreeing on some number, can you guys guess what that number is? You don't have to tell me like exactly what it's called, but guess what it's being used for? It has to do with this. Any thoughts? So basically that number basically tells you how many sort of like bits per second it is. So that number is basically telling you how fast they're talking. And by agreeing on that number, the two devices can say, this whole length is a bit versus this whole length is a bit. Does that make sense?
How do you know which number to use?
That's a good question. You can use any number you want for both devices, so long as it's the same. Disadvantages versus advantages are, higher number means you can send a lot more information faster. The disadvantage of that is the more information you're sending, the faster you're sending it, the higher the probability of some of that information being corrupted is. Because if I try to tell you like a lot of things really quickly, chances are you're going to miss something. Something on the line is going to go wrong, something in software or hardware is going to mess up and you'll miss part of the message. So you have to decide when you're using these devices, like if I need to send information really, really quickly, do I have code or hardware that will catch these errors and handle them for me? Does that make sense? For most of your applications using serial, like it generally doesn't really matter what rate you're using. I'd really default to like a lower one, like 9600, which is a standard. Why it's a standard basically has to do with the fact that this is implemented in hardware, so it basically it just works nicely with Arduino's hardware, that like 9600 number, that 11500 number. But yeah, it basically depends on how much information you need to get past quickly. Does that kind of make sense in terms of serial, like how it works? And remember the number we were talking about, does anyone know what that's called? Like the 9600 or 115200 or? Yeah, baud rate, exactly. Which and it's basically the bits per second. Yeah, cool. Any other questions about this? Does that make, yeah?
Oh, why does it go from RX1 to TX2?
Yeah, so basically this would be the Arduino, and the RX, so this, if the sensor needs to say something back, the sensor's TX line would send it to the Arduino's RX line.
Okay.
So Arduino receive from the sensor transmit. Same thing, Arduino needs to tell the sensor something, Arduino transmit, the sensor receive.
But why? Oh, okay.
That makes sense?
That makes sense.
Yeah, okay.
In my project, I have to initialize a different variable for RX and TX and have it in a different serial pin.
Yeah.
So what's the purpose of doing that?
Yeah, so that's because does anyone know on the Arduino what pins are for RX, the Uno, were for RX and TX? 0 and 1, exactly. But you're not using those, are you?
No,
What are you using?
5 and 6 were
Yeah, so you know how I said the clock rate has to do with the hardware in the Arduino? The Arduino has specialized hardware for exactly this kind of communication. Like it's built exactly for UART. So the problem is, the Uno only has one of those kind of exact hardware sort of setups for that. But you needed more, right? Because you wanted not just to talk to your computer, because on the Arduino, the 0 and 1, if you're not using it for a sensor, you can use it to talk to your computer over USB. But you want to simultaneously talk to your computer over USB and talk to a sensor. So in order to do that, you actually do something called software serial, which is basically emulating everything the hardware does with code. So basically, that's why you have to tell it, these are the pins I'm going to be using to basically emulate hardware using using software. Actually, have you guys heard of emulation or emulators?
Maybe I'll look at Kai.
Kai, what's an emulator? By the way, Kai's project is actually a video game emulator. So what's an emulator?
Well, specifically my project is just, I use a Raspberry Pi and download ROMs onto the Raspberry Pi, which emulates games, it just plays games on computer screens.
What kind of game?
Well, like Nintendo 64 and down.
Yeah. So the point there is, it's kind of like emulating a Nintendo 64. It's pretending to be that hardware so it can perform a task that's suited specifically to that hardware. What was your question?
Could you use a breadboard to connect your RX and TX to it and have multiple RX to TX, or would that be not necessary? To have multiple.
If you were sending the same message,
Different messages.
if you're sending different messages, you could do that, but you'd have to have some kind of complicated circuitry to make sure you're talking to the right person. You'd have to be shut down this line, so I get from this person. Does that kind of make sense? For example, you might have a switch that goes back and forth between devices, and that would work. It would just be some complicated circuitry. And sometimes there's better solutions to that. Usually stuff like I2C and SPI are better suited to using multiple sensors. Any other questions about UART or serial?
And if you wanted, are you allowed to redefine because RX and TX are kind of keywords on the pin?
Mm-hmm.
Is there a way that you can redefine the 0 and 1 pin so that it will fit what you want to do? Because if you're using RX and TX for a pin 5 and 6, and you change 0 and 1 to a normal pin.
Just like a normal digital I/O? Yeah. There's no reason why not. They're just if you want to, you can hardwire them to that special hardware. Cool. Some really good questions. Anything else, guys? All right, let's go to the next thing, which had the most votes, which was common/ground. Okay, you guys want to hear about that one next? Cool. Does anyone know what ground is and why it matters?
Because you need a reference point.
Exactly, you need a reference point. When I talked about Ohm's law, for you guys that were here, does anyone want to remind me what voltage is? Oops. Just any thoughts on voltage? What is voltage? How do you describe voltage? You're raising your hand?
Oh, sure. It's electric potential.
Exactly, it's potential. And what do you mean by electric potential? What is... I have no idea what voltage is. What?
Oh, it's a difference, it causes the pressure of the electricity to flow.
Yeah, the keyword to use there is difference. That's a really important thing that's tough to understand with voltage. Let's say that I had a battery. Here's the plus side and here's the negative side, right? And let's say that I wired this to a motor. Let's just say this is a motor. What's this motor going to do? Nothing. Why is it not going to do anything? Look, I connected it to the positive end of the battery.
Because it's not connected to the negative.
Why is that be connected to the negative?
To complete the circuit?
To complete the circuit, right? Because it needs to see, sure, this is at, let's say this is a 9 volt battery, right? Sure, this is plus 9. Plus 9 compared to what? Right, the key is that this is not just 9 volts. It's 9 volts here greater than here. The fun thing about voltage and potential is that it's all relative. Like Suchi said, it's a difference. If I wanted to, I could say that actually this is 1,337 volts, and then this is 1,328 volts. And now on this side, that would be totally valid. There'd be nothing wrong about that. But electrical engineers don't do that because we don't hate ourselves that much. Usually what we do is we pick a node that makes sense and call it 0 volts. And that's ground. So ordinarily I would just drop this right here. This means ground. And that means I've now defined for everywhere else in the circuit voltages. So basically what I'd say now is, since this is ground on this side, this is 0 volts. Well, this is a difference between these two in 9 volts. So this node has to be 9 volts now. It can't be anything else. Previously, like I said, I could have made it 1337 and this one 1328. And that would have been totally valid because the difference between them was 9 volts, but it doesn't make sense because it just makes everything else really annoying and difficult to read. Does that make sense sort of in terms of difference and like what ground is used for? And here's why the ground is important. Let's say that I had the Arduino. This is a common symbol for like Arduino and similar things. Does anyone know why? Does anyone know what this symbol is? Mu. Does anyone know what mu is as a metric prefix? Microcontroller. So it's a neat little thing. So this is RX. That's TX. The thing we were talking about before. And here's, let's say, a sensor. Let's say we want to hook these up. So let's do this. Did I do anything wrong so far? Mm-hmm. What did I do wrong? Yep. So RX to TX, TX to RX. Great. Is this going to work for them talking to each other? I hooked up RX to TX, I hooked up TX to RX, right? That should work, right?
There's no power.
There's no power. Okay, that's a good point. So let's say I hook this up to like, I don't know, plus 5 volts or whatever. And then plus, let's say this is like power, or sometimes like VCC, I guess. Cool. Is it going to work now? Hands up if you think this will work. For them to talk to each other. 1, 2. Hands up if you think it won't work. Okay, a lot of you guys think it won't work. Why won't it work, Agnes?
Because it's not connected to a ground.
Yeah, exactly, because they're not connected to the same ground. So what you really want to do here is wire their grounds together, right? Because, again, the problem is that this guy, until we do this, until we give them the same thing to start with, this could just as easily be, if this connection isn't made, we have the same problem where like this is 1378 volts, and this is negative 24 volts. Well, when you connect them, they're talking different languages. They're not working from the same reference point. So when this guy tries to send over 5 volts, he'll interpret it as like a negative 19 or what, like it just won't make sense, right? Because they're not working from the same starting point. When you connect them together though, now they're working from the same starting point, which means when they send like 5 volts more, the other one understands that's 5 volts more. This is 0, this is ground. Does that make sense? This is not like tying your grounds, not connecting your grounds, is one of the most common problems you will run into when trying to get separate electronic devices to work together. Like, there are people who, like, in university, I've seen, like, senior electrical engineers be stumbled on a problem for weeks and then realize they forgot to tie their grounds. It happens a lot. So, this is important. Cool.
So I don't understand like why wouldn't they be able to function without like the grounds being?
Why they wouldn't be able to function without the grounds? The idea again is, remember when I said like, oh, this node is 1337 volts and this one's 1328 volts.
Yeah.
It's sort of like that where they're working from their ground, and their ground is defined relative to themselves, right? So my plus 5 volts is relative to my ground. Your plus 5 volts is relative to your ground. Those grounds could be wildly different, but as soon as you connect them by a wire, they're instantly exactly the same potential. So anything greater than that is working from the same reference. Does that make sense?
Yeah.
Cool. Good question. Anything else on ground or common? Why it's important? Cool. All right, what's up next? Oh, we got a tie for a bunch of stuff. It looks like I didn't realize how long it takes, so I only have time probably for one more. Is there anyone in particular you guys want to hear more about? I'd say between, can you add more pins on Arduino or Pullup Resistors, because an overview of Raspberry Pi probably don't have time for. So hands up for adding more pins on Arduino. By show of hands. I was saying, by show of hands, who would prefer to hear, can you add more pins on an Arduino as opposed to Pullup Resistors? So basically, for this, hands up for this one, hands down for this one. Okay, so just to confirm that people are participating, hands up if you want to hear about Cloak Resistors instead. Okay, it looks like that's preferred. And I can talk more about adding more pins on Arduino another time, but we'll just quickly go on Cloak Resistors. Have any of you guys used a Pullup resistor? Just by a show of hands. Okay, what do you use it for, Ian?
Mine was built in, and I don't really remember why.
Okay, yeah, it's handy when they're built in, then we don't have to worry about them. Is there anyone else who had to use a Pullup resistor? No? Okay, cool. A Pullup resistor is basically, let's say that we have a switch, right? And this is actually going to work off what we were talking about with like relative potentials and ground and all that. So let's say that we have a switch that looks like this. Here's my switch with a button, you press it, right? And let's say that I've connected it to an Arduino. Here's my Arduino, and this is some input pin. So it's, and I want to read either 0 or 1. Is the switch being pressed or is it not being pressed, right? So let's say here's the microcontroller, here's the input. Anyone want to guess? So I'm going to label these. This is called, let's call this wire B. Let's call this wire A. What are things I should connect to A and B? Basically what I want the outcome to be is when I press the switch, this reads 0, and when I don't press the switch, it reads 1. And pressing the switch, what that does is, if it's unpressed, it looks like this. And if it's pressed, it connects these two wires. Does that make sense? So just literally anything, just throw it out there. What should I connect to A? What should I connect to B? To help me do that. Okay, I'll guess. I'll try something. Let's see if this works. Okay. I'm going to connect this to plus 5 volts, right? Because you know that's a 1, right? That's a high. And the other side, I'll connect this to ground, right? This is 0 volts, and this is plus 5 volts. So when it's not pressed, it sees 5 volts, right? Because this isn't connected. And when it's pressed, now that 0 volts is connected here. It's perfect, right? Is there any problem with that? Can anyone see a problem that might arise when I press the switch?
The ground's not connected to the Arduino?
So the ground you can see like right here. Let's just pretend that they are. Yeah, sorry. Yeah, that's a good point. Yeah, I should have made it more clear. Basically, yeah, with this symbol, they're now connected to Arduino. But yeah, that's a good point. So now we fixed that problem. The other problem that arises with this circuit. 0 volts, so it's going straight to the input. It should see a 0 now, right? Any thoughts? Well, did the 5 volts get disconnected from B? So 5 volts is directly connected to the input, and 0 volts is directly connected to the input. What's the issue?
That is short.
Yeah, it's short, because look, 5 volts, wire, 0 volts. We're in trouble, right? That's not good. This is, your battery's gonna get real hot, maybe blow up depending on what type of battery it is, so you wanna avoid this. So instead what we do is something slightly different. So let's say this is the unpressed state. We have and ground, which means we're not going to have that massive current. We're not going to have a short anymore. So basically, the 5 volts will all drop across the 10 kilo ohm resistor now because it has like a direct path to ground, and the input will see that direct path to ground. When it's unpressed, weak connection to 5 volts, no connection to ground, so it sees 5 volts. Does that make sense? Cool. So pullup resistors are pretty common in 2 situations I can think of. One is for like switches, and like again, just if you have a switch that's either closed or open. The other situation is for something called I2C, which is it's similar to serial. It's another way of devices talking to each other. And in the I2C, you need pullup resistors because the devices, when they control the line, they're only capable of pulling it low. So they need something to keep it normally high. Does that make sense? And my last part might have been kind of confusing. I talked about more later. But I think it's almost, or just past, what's up?
What's the difference between a pullup resistor and just a regular resistor?
This is just, they're literally the same component. It's just, you call it a pullup resistor because it's being used in a situation. Yeah. I'm trying to think of a good analogy. Can't think of anything.
Is the pullup resistor like specific to only one part of the circuit, whereas?
No, like I could use this anywhere. This is literally just a resistor I pulled out of the back of my circuit. It's just being called a pullup resistor because it's being used for that function. Yeah. I guess it's like, I don't know. You know, if you're driving a car, you're a driver, but you're also still a human. You can do other things that humans can do, but in that specific instance, you're a driver because right now you're driving. Is that a good analogy? I don't know.